So I'm Rick Anderson. I'm Director of Virtual Worlds with Rutgers University. I'm also co-founder of the New Jersey Makerspace Association at Rutgers, as well as co-founder of FUBAR Labs, Fair Use Building and Research and Makerspace in New Jersey. And I'm really involved in that set of communities. Today, what I'm going to be talking about is sort of what I've done as Virtual Worlds for Rutgers is build out the virtual campuses. I have 3D versions of buildings and roads. I have a lot of these resources. And the idea is that some parts of this are open source, and we need to be able to not just create everything from scratch, but we would like to be able to build out that environment and integrate it into multiple projects. And so part of what I'm going to talk about is how I see that relevant, as well as sort of the Arduino real low-level stuff. How does actual hardware fit into a virtual space, as well as the principle of, in this case, restful virtual environments. So we had a little bit of programming, sort of web services in the mix of that. So one of the ways I got to the point about simulating vehicles was I have a capstone group that I sponsor in the makerspace at Rutgers University. And in that space, the capstone students have to choose what kind of project they're going to do. So since I had a batch of assets, we use Unity 3D. I have the buildings. So the idea was that they would build a Rutgers virtual tour where you were driving the bus around campus. So in this case, you actually have the steering wheel and the foot pedals, and I actually have the demo in the back of the room. So after the presentation, you guys can actually, kind of maneuver these buses around if you want. And so I'm using the Unity game engine for that, and that ties in with sort of the local community of people that are familiar with Unity 3D and get that going. And the other part with using that particular technology was that I can do web-based desktop, console, iOS, and Android type applications. So you can start in one space and go into many others. So I'm really interested in making what we do relevant in all of those different spaces in terms of devices as well as in terms of projects. Ben in the audience is here. He worked on Rutgers Virtual Tour, big heavyweight in terms of making that happen. So part of our conversations later, we're going to actually talk to some of the people who worked on those projects directly. So now a little bit more of the low level end of things. How do we we talked about with Tyler's presentation, he's got a vehicle, it's collecting up data, is creating a virtual interface, and that data and virtual interface have to work together, but you have to have some way of making those communications work and then play them back and re-simulate them. So one of the things that I'm borrowing from a lot of sort of web services and Web 2.0 thing is that restful idea that you have put, get, and all the post and all the various parts of what a service is. But what I'm doing is saying that you can put them inside of basically an Arduino and simplify it too, because these tools are really, they're an appliance as opposed to the Raspberry Pi, which is actually a mini computer. So the appliance is designed to collect up things like joystick position. It might be a microwave. It can be various things that concentrate data and then have a limited set of actions. So what I did in this particular example is I've got an accelerometer, so it's telling you position, joystick for controlling a location, buttons that interact, and potentiometers that are basically a range, a knob, and twisty dials. And all of that's returning back JSON data. So in terms of what the computer sees, it's actually this basically key value pair set where I have accelerometer 75, button 1 is true or false, and it's just the real guts of it. But what it turns out is that it's really just reading the information from this set of equipment here, and with about 100-line program, I'm pulling data off, and I'm able to take that data and do something more interesting with what that means. So now that I've got that control data, I actually are kind of okay, well, I have one device that's telling me something. It's over this particular serial cable that I have here, and it's plain old serial data. And serial data is, basically one character after the other. It's not networked. So we need to find a way to say, I've got in my vehicle multiple what they call car area networks, and I want to be able to coordinate information from those things. But I also might want to be simulating more than one car at a time. I might have different devices that I'm trying to pull that data in. So basically, the JSON information would structure it, but now I want to network it. So in the case of the example, I have some code that's actually reading the serial data in, and then it converts it into what's called the UDP protocol, and it just fires the information over that. But UDP by itself is nice and speedy, but what it doesn't do is guarantee sequence and order or a bit of accuracy and some checking. So there's an open source protocol called the Open Sound Control Protocol, and basically it sits on top of UDP, coordinates a lot of different information, and it's designed for music devices and things that have to be highly synchronized. So that allows me to coordinate a lot of different data. And so what I do is I read that serial information, bring it to some device like the computer, and then translate that into network data. So now I could have multiple laptops with multiple joysticks and accelerometers firing data in. But this could also be CAN bus data. It really, as long as it's just formatted properly, we're getting the information we're looking for. Then on the other end is you need a technology that's going to pull that in. So the Unity game engine, I have a module that's also open source control compatible, and it says, oh, I've got an OSC device. Now they talk to each other. So once they're talking to each other, I'm actually passing the data back and forth. So I'm just going to do a quick demo of, how that, what does it turn out to be? What can it do? So I need to pull out of the full screen here for a second. Sorry, there. So I have a basic demo that is called the Unity Box Bomber. So when this fires up, it actually is loading up the UDP server, and it gives you a set of options. So I can take the serial data directly into the program. I can have open sound control version and a mouse version. So there's multiple ways to interact. In this case, I'm doing the open sound control version, and I'm grabbing the bomb tool. So as I move the joystick around, I'm dropping a whole mess of blocks. And then if I press the right button, it starts dropping bombs on top of the space. And then it has acceleration data, so I can start actually interacting with those objects. And so what we're seeing is we're not really getting much lag from having this much data in here. And it's coming directly off of a device inputted into the system. The nice thing about this structure is that I can have multiple controls across multiple computers over the network, giving this stuff over UDP. So you could make a multiplayer version of this type of a game. But thinking about it is that this is more than one vehicle you might be tracking. So the technique is actually generalizable to the larger situation. So that's where I'm like, this network data, it's the RESTful interface. It's the type of programming that the software level that a lot of people are used to seeing, but this is coming out of a hardware interface, and a very simple one. In fact, I'm using an environment. This particular board is an Arduino, but it's an Arduino compatible. It's a chip kit board, and it runs a certain number of times faster and can do a lot more data collection. So I'm going to come back to that later. But what I wanted to also say is that I want to show the Unity environment and what it can do in terms of simulation and AI. So I'm going to pull that up real quick here. So I have, let's say we've got the idea that we want to simulate a vehicle. So in this case, it's just a simple setup where we have one vehicle with a simple AI, and Brian in the audience put together that particular scenario. And these are sort of like, if we're thinking about vehicle simulation, this vehicle has a set of waypoints that it's trying to hit, and of course it's doing it at like 90 miles an hour, as fast as possible, not very smart. But what we're going to do with this project is try to make that AI better, try to make this world much more interesting, and see what happens. So right now we're just looking at one car, but I think one of the things that we can think about is that this sort of project has this ability to scale and understand the scale, and scale the AI as well. So I have that same simple setup here, but I have, I think, like 64 cars on the road. Of course. So I think if we have a better algorithm, right, they probably won't be mashing into each other quite so thoroughly. But I think, if you got to start someplace. So if we were starting with vehicles, there would be, not a lot of humans left. But the thing that's really interesting is the emergent behavior here is that they will push each other across the finish line eventually. So there's emergent behavior that you may not really want in real life. But so the thing is, this actually shows I could actually get up to about 300 cars before I'm actually maxing out this system. So sort of like between the smarter the AI, the maybe 200 cars, So the idea is that we want to be able to make that scale possible and think a little more roundabout for that. So that's definitely, I think, in terms of the game engine stuff, when we really ramp that up, we'll be able to see a lot more going on. Then I just want to kind of jump back to the hardware a little bit. This particular hardware has some features. It's a 32 chip. It's very smart. It's still an appliance style. But what it also has is a thing called CAN bus on it. And we can actually take the data that we're collecting from the vehicles and coordinate it into a CAN bus device that will relay vehicle data. Are the doors opened or closed? What's the engine doing right now? Are we locked? Are we unlocked? Its car state can be determined and then concentrated into sort of like a chip kit board like this one. And then using that RESTful interface, we can basically say, well, let's put an onboard Wi-Fi, let's throw Ethernet on, let's throw Bluetooth LE on here. And you can send that data out to other interfaces, but eventually get it back to that game engine where you have all the craziness, of simulating multiple real-life vehicles. You can record that data. The other goal is to record the data, play it back, so you can take a real-life simulation, real life, and then go simulate it again virtually. The other thing I want to say is, in terms of Arduino technology, we also have Jason here, who worked on an autonomous RC car. And so there's some hardware people in the audience that I think would be really good to talk about, because when Tyler was talking about Kalman filters and other sorts of things, Jason's gone through that, solving it on the RC car. So I'm just going to leave you guys with the RC car video here. If I can, I'll see about boosting this up. Oh, I'm not in play mode anymore. Let me fix that. So there we go. So anyway, whoops. Back, vehicle, bigger. So this is the autonomous car, little RC running around the parking lot. And this is using GPS points. What is it? And as Tyler pointed out, GPS isn't the best of things. It gives you some waypoints that you can achieve. But it's not the solution. So like he had the Raspberry Pi doing OpenCV and other data collection. So anyway, you can set up map waypoints, and then in the parking lot it can hit those points, but it has to have, if there's obstacles, you have to set up a way to get around those. So anyway, this is the RC car style stuff, so you can simulate on a small vehicle all the way up to the big vehicles. So I basically want to kind of let you say this all kind of coordinates together. You'll see it on the small to the large scale. So I love the fact that the Elcano project has many different types of vehicles that are running and you can test with. So then the only other part is that as much as I try to make open source and available, and I think Profil has made that available on the GitHub account for the self-driving vehicle. So the code that I talked about, Node OSC using Unity, the Unity environment, all of that is over here for you guys to check out in the self-driving vehicle GitHub. So as it goes, that's pretty much the story for now. I want to help do some coordination and see where there's fits and look at the big picture a bit. But that's pretty much it. Questions or wherever we're with this, we'll take them at the end. So, all right. So I just go wrap